Okay. So what I would like you to do is I would like you to take these points, the velocity, transverse velocity, and the acceleration at each point. Positive x direction. What's going on at point 1?
At point 1, you're on a zero slope.
Good.
So velocity is 0.
Very good. Because that's right at the very peak. We know that it's going to be 0. What about
now,
a sub y?
A sub y.
I mean, the easiest way to look at it is just look at the concavity. It's concave down that way.
Negative.
It's concave down, the acceleration's that way. Less than 0. Okay?
Okay.
All right, let's look at point 2. What's going on in point 2? Okay, so let's go over the concept. So because we're moving in the positive x direction, what you need to do is you need to stand here as if you were sitting at 2 and move to the right. What is the point going to do? It's going to ascend, right? It's going to go up, so therefore the velocity is greater than 0.
Okay.
Stick to this. If we move to the right, it moves up. It should be greater than 0. Okay?
Okay. I'm with you.
This is point inflection is roughly about there. So we have now switched from a concave down to a concave
up.
So therefore the acceleration is
positive.
Good. All right, let's look at point 3. Point 3, if we're standing right here and
we move to the right, it's decreasing.
Decreasing, good. So the velocity would be less than 0. Do you see how we did that?
I see how we did that. And since it's on a concave down,
good.
It's negative.
Good. Getting a little clearer?
It's getting clearer.
Okay, so let's look at point 4. What's going on at point 4?
Point 4, the velocity is 0 because it's at a 0 slope.
Very good.
But since it's smiling, it's positive acceleration.
Good. Greater than 0. It's concave up. This region right here is concave up. All right, so then point 5. What's going on at point 5? At
point 5, you have, if you move it to the right ever so slightly, it's going to be decreasing.
Good. So if I went that way, we'd start going down. So the velocity is?
Less than 0.
Good. And then?
The acceleration is also less than 0 because it's on a concave down.
All right, good. Very good. So now?
6. Like for most of these, you go from wave to wave.
So
from wavelength to wavelength.
They're looking at the rest of it?
Yeah, like they're looking at the rest of it. They're going from wavelength to wavelength.
Yeah, I guess you do have to cross the critical point before you make your assessment. And that curve is going up a little bit. What about the acceleration, though?
The acceleration would still be positive because it's on a concave up.
Be careful. Okay, this is unlike any of them we've seen because all of the points have been on a curved portion of the curve. Okay, there's some curvature going on, so there's acceleration. Look at our slope here. So let me do it in blue, maybe. Slope is pretty much a straight line, right?
Yeah.
It's constant. What does it mean when our slope is constant here?
That means that the acceleration is 0.
0. Good. All right.
All right.
You feel better about this concept now?
I feel better about it.
Good. We'll do another one of these in a little while.